I'm just copying the information and then I will stop sharing. Adult citizens of a nation found that 15%, so that's P hat coming from the sample, a national survey. Oh, a national survey, okay, but still a sample of 1,500 of a nation found that 15% dreaded Valentine's Day. Okay, so that's coming from the sample, so it's P hat. The margin of error for the survey, E, equals 4.2 percentage points, which has to be changed into 0.042. Okay. With a 90% confidence interval. Which statement below is the best explanation? I don't know. I have to perform some calculations. I have to stop sharing. Right? Explain what this means. So let's talk about it for a moment. So what does this mean? Is that, first of all, P hat equals 0.15, which is X over 1,500. So let's see how many. I just need to calculate a few things and discuss the whole problem. Cross multiply. So let me write it for you. So it's 0.15 times 1,500. 0.15 times 1,500. And I got 225. Okay. Then the margin of error means that there is a confidence interval that is confidence 90% confidence interval is P hat 0.15 minus the margin of error 0.042 comma 0.15 plus the margin of error. And this is the 90% confidence interval. So I will calculate now and give you the exact interval. So 0.15 and minus 0.042, that's how lazy people do it, 0.108, comma, and the other one with plus, 0.192. Okay. So it means that, and then we'll go and check and choose whatever we need to choose from there. So this means that if we repeat the experiment 100 times, and we create every time we create a 90% confidence interval, and we repeat them, as I said, 100 times, 90 out of 100 intervals, because they will always be different. If I select another 1,500, I'll get different answers. If I select another group of 1,500, I'll get different percentage, and so on and so forth. These will all be different. But if I repeat the experiment 100 times, 90 of those are certain, we're confident, if you want, that 90 of those contain the true population proportion. And now I'm going to share and read what they want. I don't want to bother to read before we perform our calculations. There is 90% confidence that the proportion of the adult citizens of the nation that dreaded Valentine's Day is between, yes, I performed my calculations, that's what I got. So I have a 90% confidence that the proportion of the true population proportion of the adult citizens of that nation that disliked Valentine's Day is between 10.8% and 19.2%. For the sake of the argument, let's read the other three. There is 85.8. Where did they come up with that? No. That 15%, no. In 90% of samples of adult citizens of the nation, the proportion that dreaded Valentine in 90% of samples. No. No. The population, the proportion that, and it's interesting how they twist the words. In 90% of samples, the proportion that dreaded is between this and this. No, it's the 90% confidence. Okay, no. Let's also read D. There is 90% confidence that 15% of the adult citizens of the nation. No. So the correct answer, C, is very nicely twisted. Be very careful. I am not a perfect English person, as you've noticed. So I have to read this very carefully. So there is 90% confidence that the proportion of the adult citizens of the nation that dreaded is between this and this. In 90% of samples of adult citizens of the nation, in 90% of the samples, the proportion that dreaded is between this and this. Very close, but I would still stick with there is 90% confidence. The proportion, I will stick with this. Although it's a very fine in 90% of the samples. No, it's not in 90% of the samples, is in the intervals. The proportion is between. That's my pick. Although, again, if you're not a super English person, you may have difficulties like I do. I have to read very carefully because they can catch me. So careful with that. Very good question. Thank you for bringing that to our attention. Good. Next, is there anything else? See how fine a fine line is between nuances? So be careful with that. I certainly have to be very careful with that. Is there anything else we need to do here, or we go back to our lesson? We continue and try to finish chapter 9. Okay, you can always stop me. I'm going to stop sharing. Okay, ready? Okay, so we continue now. We already know how to estimate using a point estimate and a confidence interval for population proportion. Now we're going to go back and do exactly the same thing. It's slightly different, but exactly the same idea. But this time we want to estimate the population proportion, population mean, not proportion. We've done so far. So far we're finished with that. We'll kind of come back later, though. So again, the point estimate for the population mean is the population is the sample mean. So I have a sample mean. I have a sample here. The website such and such allows drivers to report the miles per gallon of their vehicle. Fine. The data show the reported miles per gallon for 2011 Ford Focus for 16 different owners. We have 16 entries. You can enter them in StatCrunch. Obtain a point estimate of the population mean in miles per gallon of such and such. Mean miles per gallon of 2011 Ford Focus. You can use StatCrunch, or you can put it in the data. Put the data in the graphing calculator. I'm going to do just that. 35.7. There are only 16. 37.2. 34.1. 38.9. 32. 41.3. 32.5. 37.1. 37.3, 38.8, 38.2, 39.6, 32.2, 40.9, 37, and 36. Do I have 16? I do. And then very easily I go to stats, calculations, one variable stat, list L1, yes, 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 done. So I have for the first example that X bar is a point, oh, I forgot to write 9.2, estimate of mu, population proportion. So X bar is a point estimate for mu, and in this case, I have X bar, which is 36.8. That was our first example. Now, I have to discuss what this is all about. Okay. We remember that Z is what is called standard normal. And this is normally distributed. Anyone remembers the mean and the standard deviation for Z?
0,1.
Very good. 0,1. There is also a distribution that is called the T distribution, also called student. The person who invented it didn't want to use his name, so he called the student's T distribution. Okay. T is a ratio similar to Z. Let me refresh your memory what Z was. So Z was the entry minus mu divided by sigma. So any entry minus the mean, population mean over the population standard deviation. Okay. However, this T, which is the mean of the sample minus the mean of the population divided by the sample standard deviation divided by the square root of n, this has that's why it's also called T. It has a T distribution. What's the difference between these two? One thing that I should say immediately is as n increases at least 30 or more, but as n increases the sample size, increases, let's say, I shouldn't say infinity, but increases, then T is approximately Z. Now, T also has a characteristic that Z does not. T has different shapes for different, and we encountered this before, degrees of freedom. Degrees of freedom are always n minus 1, the sample size minus 1. So if this is the normal distribution, standard normal, with 0, 1, then T may look like this with wider tails. And as n increases, so let's say I'm going to say that this is for degrees of freedom 5. But as the number of degrees of freedom increases, they get closer, the graph gets closer and closer to the Z distribution. So as n increases, T is approximately Z. In other words, if we have a large number of sample size, you will see, and we can always do that, if you apply the T distribution or the Z distribution, the error, there will still be a tiny error, but it will be very small. Okay. Question, why do I need T? Why? Well, whenever the sample size is less than or equal to 30, even if the population is approximately normal, it is recommended to use T instead of Z. That's one example, one reason. Reason number 2, we use the sample standard deviation, not the population standard deviation. So for these two reasons, when the sample size is less than or equal to 30, even if it's coming from a normal population, but because also we use S, because we do not have, this is a point estimate of the population standard deviation, it is recommended to use the t distribution. Okay, so now let's see. I listed here everything that I already mentioned. It's a bell-shaped, it's symmetric, is centered at 0. But we cannot talk about standard deviation. We talk about degrees of freedom here. The area under the curve is still 1 because it represents probabilities, and probabilities cannot be more than 1. So it's bell-shaped, it's symmetric, it's centered at 0, but with longer tails, more area in the tails than the normal distribution, the standard normal. They are thicker tails, but still the area total is still 1. More area found in the tails than in the graph of z. As n increases, the distribution of t approaches the distribution of z. Different bell-shaped curve for different degrees of freedom. Because we use S instead of sigma. It has more dispersion than z, a little bit. And the same thing, y equals 0 is the horizontal asymptote. Eventually, both distributions will approach 0. They have to close up the 1. Okay, so here's our first example.